In this video, let's talk about a lasso regression. Lasso regression. Lasso regression can also be called as L1 regularization. This is also called as L1 regularization. Why we are using lasso regression? Main thing to prevent overfitting problem, and also to have a good feature selection by removing unwanted features. Okay, so this is also a regularization method which will help us to reduce overfitting and also for future selection. Now, this is similar to ridge regression, except to a very important difference that penalty function now will be equal to, let me take here this color, penalty function will be here equal to lambda into modulus of slope. Earlier it was a slope to the power of whole square, right? Here in this case, lambda into modulus of slope. Now let me draw a graph here. Let me draw a graph here between x and y axis. Now what I'm trying to do here is I'm trying to put 2 points here. There my regression line will be passing through this point, and say that it is passing through intercept 0. Now this is my overfitting line here. Now similar to like ridge regression, we have we have uh, we have a line here which will be passing through, sorry, which can be passing through with some amount of slope through this, right? Now let us say this is our lasso regression line, right? Now, like rich regression, this will also do some similar things. In this case, you know, why we are using a lasso regression, we already talked about, to prevent overfitting right now. Now the result of lasso regression is quite similar to the result of ridge regression. Ridge can only shrink the slope asymptotically close to zero, right? In ridge, what it will do, it will take the value closer to zero, but in lasso regression it will make the slope all the way to zero. It will make the slope to reach until zero actually. So the advantage of this is quite clear when we have lots of parameters in this model. Let me have something here. Let me write the cost function here. Let me say that cost function. I don't want to write the formula, like cost function, which is j theta naught comma theta 1, let us say, and then our lambda into modulus of slope. So this is the formula what we have here, right? Now how does it make a good feature selection here? Now what it will do here is it will take h theta of, we already know that h theta of x is equal to theta naught plus theta 1 into x1. We have lot many features, right? Theta 2 into x2 plus theta 3 into x3. We have so on till theta n into xn. Let us say we have n features here. Now what actually it will do here in this equation, we are, it will be taking something like this, lambda into modulus of theta naught, theta 1 plus theta 2 plus theta 3 plus theta 4 and so on theta n. So what it will be trying to do here is, in this case it is not happening the square here like in our ridge regression. It is just a modulus of the coefficients here. Now what actually happens here? Now when we are trying to optimize the cost function, when we are trying to optimize the cost function, the values of the coefficients in this slope, the coefficients here will turn 0. It will reach to the value called 0. Some of the coefficient will reach to the 0, which will help us to have a good feature selection here. So that is why lasso is important for overfitting as well as for feature selection, right? Now this will improve our performance metrics, and it will iterate. It will be having a values of r square and adjusted r square. It will iterate through over multiple times, then finally it will reach to some value which can improve the performance metrics. Now here lambda again, which is called as a cross validation, right? Now in Lasso, when we increase the value of lambda, the most important parameters shrink a little bit, right? And less important parameters go close to zero. So here in this case, Lasso is able to exclude silly parameters from the model. That's how we will get some good parameters in the feature selection. So this is about lasso regression. We'll see some more algorithms in our next video. Thank you for watching.